Welcome back and happy Monday. Hope you all enjoyed your weekend. Today we're going to be talking about the actual formula for exponential growth and decay. We're going to start breaking that formula down and learning how to use it. Now we've seen it in the pieces. Right? So the idea is that we've got this formula for exponential growth and decay. This isn't just a regular exponential formula. This is a special one. It's especially designed for growth and decay. So the numbers have meaning. So first off, this A number, the y equals A. That A number there, that is our starting value. However many we start with at the beginning of our count. It doesn't have to be at the start of time. It just means we started counting on Tuesday, and on Tuesday there was 73, ducks in the pond. It doesn't matter what you're actually counting. You just need to know where you started counting. All right. The next thing you need to know is the rate. It's the R number here in the formula. And again, that R number stands for rate. That means we need to know how fast the item is growing or decaying, meaning shrinking. And then the last thing we got is T. That's the exponent. That's the time. And that could be in any form of measurement. That could be in days, months, years, weeks. Again, it's important to note what value it is. That way when you finish your answer, you don't end up saying something takes 14 years when really it takes 14 minutes. So the unit of measurement will be extremely important, but that's always the time measurement. All right, so let's look at some examples. All right, so we've got a formula already set up. And first question is this growth or decay? So to find out if it's growth or decay, what you're looking for is essentially here. You're looking to see if it's an adding to one number or a subtracting to one number. If it's adding to one, it's growth. If it's subtracting, it would be decay. All right. Part B, what is the initial value? Well, the initial value is this number here in front of the parentheses. So for whatever situation this is, the initial value was 900, meaning that's how many there were when you started investigating whatever situation this is. All right, then last part, what is the rate? Well, in this one it's easy. The rate's sitting here staring us in the face. It's 0.02, but we have to change that 0.02 into a percent, so we move the decimal 2 spaces, and we end up with 2% rate. All right, so something's growing. It started at 900. It's got a 2% rate. The only thing we need now is to know the time. How long are we going to wait? 2 years from now, how many of these things are there? 5 years from now, how many of them are there? Whatever they are, whether they're, some invasive plant or, number of fish in your pond. I mean, it doesn't matter what it is that you're counting. If you have the initial starting point and you have your growth rate, you can find out how many there will be down the road, assuming that everything stays the same. That's a pretty big assumption, but that's the idea. All right, try another one. First off, is it growth or decay? So to find out if it's growth or decay, I'm looking for that subtraction or addition sign there. Since we've got a subtraction, and this one's decay. Next, what's the initial value? The initial value is always the number out front of this parenthesis here. 12,000. Well, that's a lot of whatever it is we're starting with. We have 12,000 of them at the beginning. And then what is the rate? So that rate is the number that's after the 1 plus or minus part. So in this case it's 0.025. I move that decimal point 2 spaces, and we end up with 2.5%. Now let's try a little bit harder one, but again, this isn't that much harder. This is all the same stuff. It's just a little bit trickier because the work that's in the parentheses has already kind of been simplified. For example, in the last one, it said 1 minus 0.025, and in this one, they've already gone ahead and finished that calculation. So there isn't a plus or minus sign there. So how do I know if it's growth or decay? Well, if you start with a 1 and add something to it, that means you're going to have a number bigger than 1. If you start with 1 and minus something from it, you'll have a number smaller than 1. So for example, if I go back, this example, since it was plus, if I actually rewrote that, it would be 900. I could write that as 1.02 to the t power. Go ahead and add the 1 plus 0.02. Since this answer is bigger than 1, I know it would be a growth. Whereas in this one here, if I went ahead and subtracted, that would be 12,000. And then 1 minus 0.025 would be 0.975. And you can see that this number is smaller than 1, meaning that we had to have subtracted to get to it. So since this number is bigger than 1 on this example, we know that that was really a 1 plus 0.14. That's how we get it. So that's a growth. It's 0.14 larger than 1. All right, so what's the initial value? Well, that's, again, always in the same location. This started off with 5,000 or whatever it is we're counting. And then the rate, well, again, that was the part that we either added or subtracted to 1. So in this case, it's 0.14. And we switch that to a decimal or a percent. It becomes 14%. So again, a little trickier because they've already gone ahead and either added or subtracted that number in the parentheses. And you kind of have to split it back out. But it's not very hard to split back out because of that 1 that's right there. All right, let me know if you need any help or if you want to check any answers. I'm available to help you out today. Good luck.